Hello everyone. Due to popular demand, I'm going to create a brand new model in Trnsys and program it and show you how to create the .dll file, which will allow that model to work within Trnsys. Alright, here we're going to use a simple example on convection. Okay, heat transfer through convection. Now we have this example. This question says a 2 meter long 0.3 cm diameter wire extends across a room at 15 degrees Celsius as shown. Heat is generated in the wire as a result of resistance heating, and the surface temperature of the wire is this. In steady operation, also the voltage drop and electric current through the wire are measured, blah 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 blah. Alright, so this is the question. What we're really interested in is this formula to get this working. You can see from this formula that the coefficient of heat transfer is H, while the heat transfer by convection is Q. A is the surface area, T is the surface temperature, and T infinity is the surrounding temperature. So H is the output because it's going to be the answers from this input when they are computed. Every other thing on the right hand side is the input. So we're going to model this using these given values to see how this heat transfer coefficient changes with change in temperature, in surrounding temperature. Alright, let's go straight to Trnsys. Go to new component, create. Alright, so we can call this you can call it whatever you like. Sample convection. Alright, I want to name this, let's say I use a number like 400, okay, 500 for example, and allow my instance 1. I need to choose an icon, and because I don't have a readily available image, I'm going to call up Paint and open that up. Then I go back here. This is the wire in question, so I will have to capture this. I just come here and capture this. Okay. Okay, and then let's resize this so that it doesn't take too long to load. We can save this as bitmap, PNG 24-bit. If you're not sure what to do or what to choose, you can come here, save as BMP. It will automatically select 24-bit for you. You can call this type 500. Then you save it into the Proforma folder for Trnsys. I have mine on my document. So we go straight to Studio, Icons, type 500. You save. This is where all Trnsys Proforma icons are saved. We close this and we go back here, go to choose. Alright, so we can come straight here and Q convection. Unit is in watts, is power. Is in 90. This is input also. Area. We also have okay. Okay, so now we create another one, say modify. We call this H, which is a heat transfer coefficient. This is output. This is where can I find specific heat? No, not this. Yes. Let me see whether I can find heat transfer coefficient. Yes, this is it. Alright, so we leave here blank because we don't have a value. We change this to output, no value for this guy, we're okay. Alright, for this one, we have a value for area. The area is 0.0188885. That's the area. 0.01885. We also have a value for surface temperature, which is 152. And we also have a value for this guy, which is 15. because of uniformity in unit, we have this as Kelvin, which is the output. We also leave these ones at Kelvin also, uniformity, and then we OK. Alright, so let's go straight and save our file. We save this as a proforma. So with this, we go straight into our Trnsys folder. Go straight to Studio Proforma, and because it has to do with heat transfer through wire, you can create a folder for this if you like, but I would like to save mine into electrical, so I'll create a folder called heat resistance wire, something I can't remember. So I'll call this type 500 with no space in between. Yeah, be careful when you are choosing type so that it doesn't conflict with an already existing type file in Trnsys. So it is safe to name your file within the range of 150 to 250. So we save that. Now we can export this file. We're ready to export. We go to export FORTRAN. So we go straight into our source code folder. Create a folder, call it type 100. So while it's calling up code block, we wait. If you want to know more about creating models, just watch my first video. Alright, to successfully create a .dll file, you need to download code block. After downloading code block, you can also download a compiler called G95 from this website. You download the binaries, stable version, this is the stats, or you simply just click this link and download this file. When you download this file, you install it. After installation, you come here to settings, compiler. You go to sample compiler. That's my G95 FORTRAN compiler there, and I set it as default. You can also come here to tools chain if it's not appearing on this list, to say okay, auto detect, and when you click auto detect, the system will find it, write this all out for you, else you can also do it manually if you know the path. Okay, so after this you can close this up. Then open this, go to settings, and ensure that the directory for your FORTRAN environment is pointing at code blocks. Okay, very important. Okay, alright, now we're about to program and create a .dll file, but before we go into that, check below the link of my first video. You will find a folder called everything in this folder. Copy it if you have already extracted. Alright, copy and go to your Trnsys folder, source code, type 500, paste it in there. Okay, so when you have done this, you come here, right click, edit, run, change this figure to 500 according to the value of your model type. Save. Okay, minimize this because you come back here. Come back here again, export this guy to FORTRAN, type 500, save. Alright, while code block is opening, I need to quickly show you something. After creating this model, we can see that it's not appearing here. Okay, under electrical, when you click this tree, you can see our model is not here. So what you can do is you minimize this, start, empty project, okay. Quickly come to access tree and refresh. When you have refreshed, update project, refresh, and come back to electrical. When you see this, you can now see it's inside of the heat resistance folder. Okay, alright, so this still doesn't run, so we need to program now. So we go over to this, yes, you can see our G95 FORTRAN compiler is appearing. Say OK and OK. Then you come here to FORTRAN sources, source code, type, double click. Alright, here is our file that we have created. Starting from the top, you can see here the name, sample convection, and you can see the model we created. This is the output, and you can see the inputs that we created. And here we have other parameters set out, dimensions, the declaration of variables, and the rest of them. Trnsys has created a framework where you don't need to write all the program, but you just need to slot in a line of code where it is appropriate. So we start writing this program straight away from the top. So the first thing we'll do, we ensure you click backspace so that all this will be highlighted in blue. We're trying to debug it based on the G95 program format. You come here to kind of create a continuity after the first line of code. backspace, and then press your space bar 5 times. 1, 2, 3, 4, 5. We'll go down straight to remove the question mark and type in this formula, Q convection over area times this times that. So we call up our Q convection. That's it. You press the tab key to accept, then you open a bracket, divided by, you open a bracket, you put surface area times this minus that. Alright, so this is it. And after writing this program, you build. There's an error on line 243, which is this. You need to add asterisks there. I forgot. We compile again. Alright, this time there is no error message anymore, so we can save this program. Go back here, back to executable, copy this file again, this one, copy it again, source code, type 500, paste it here. Alright, then compile. The file will be created now because there's no error in the program. You see that it will be created here. Just keep your eyes on this program. Alright, this is our file. Tag 500.dll created. Fantastic, right? So what you now do from here is you copy this file and go back to user library. Paste it here and release. After pasting it in release, you go back to this and you come to edit and say update project. Okay. When you run this program, Trnsys checks the user library to see. So it's running now. Very good. So we're going to use this model here. We'll have to bring out an output, a printer and an online plotter. Online plotter with file, Trnsys supplied units. Okay. So we need to link this up with this. So we come here and click on link. Link this to print out this output to this guy. Good. Back here. Okay, so we click on this and say link our output to the left axis variable. Okay. So let's run this and see, but before then let's configure this. Okay, we don't have any values, no right axis values, so we can reduce this to 1. Alright, so what again. Our H is not on the left axis. What you see is temperature. Our H is not temperature. Our H is heat transfer coefficient. Don't leave any space in between, rather use an underscore, else it will not run. Since we have nothing on the right, you can take this out or leave a space that way, and okay, we're good to go. Alright, so we can see the value, you can see the equation running, the iteration running, and that's it. Beautiful. So we can come over here and still check out externally. Okay, this is our answer. At the first iteration, at 0 time, everything is initial state is 0, and we have this, which is 3.485 as the answer from the first iteration, and because it is just one instance, we're going to run this equation for many instances to see the difference. So when we come back here, this is 3.485. So when we come back here, you see we have the answer as 34.9 watts per meter squared, which is almost like 3.4. However, so let's try this equation in more time steps. Without wasting time, let me go straight to a weather file. What's a weather file for? We come straight down here and say standard format. Let's say we have let's use this. Let's see if this will run. Okay, so external file, we browse for area weather file in here, and okay, we create a link between this guy and this one. We edit this connection. Good, because we do not use dry bulb temperature in Nigeria. So we have ambient temperature, which is the temperature in the environment, and I connect it to this. You can see it went very well. So if you run this, you find that it runs for a year. Beautiful, for a whole year. This is January, February, March, April. Good. So when we come here to external, edit, you will find that here, after the first iteration, this is what went down all through the year with changes in temperature and changing day and time. So we can also come here and change the time. This is 0 to 8,760, which is a year. If you want this to run for 1 day, you say day, day, you can choose 1. In time steps of 1 hour, run. So this is just for a day. It's just for a day, from 0 hours to 24 hours. You can see at midday what the value is. Alright, you can actually zoom into this. No, you can actually click and drag over an area and zoom into it. let's blow this up. To blow that up, what we need to do is we come here to units. Because our value is very small, we can take this left axis, you can change this to 100. Good, so that we can see this properly, what goes down. You can see at midday between 12 and 2 o'clock, we had the highest temperature, ambient temperature around 2, which is here, and you can see. So that's all for creating and programming a model and then using your model within Trnsys. If you have any questions, you can send me an email or just leave a comment below. Thank you. Alright, one more thing you need to know. If peradventure you make a change to this model, let's say you decided that you wanted to change type number or add another variable, you will still have to go through all the same processes by exporting, and besides exporting, rewriting the program, copying files from executable to this and to user library, as if you're building the model afresh. So take note of this, because if you make any changes on this model and it stops working, you need to just go through the same process as creating a new one in order to effect the correction.